Okay, so we're officially getting started. We will have if you just came in, you just walked through the door, we're going to have the midterm at about 11, right before lunch. So we're going to spend the morning, well, the next couple hours here, finishing assignment number 3. And then in the afternoon, we have swing, an abstract window toolkit. So that'll be fun. Everyone likes the GUI for assignment number 4. So we're still, last time we left off, we started assignment number 3. I want to review a little bit before we get into it. We had this concept of a stock, and the stock was like a security. We buy them, we sell them. We buy them at hopefully lower prices than we're selling them for, because it's an investment opportunity. And then when we sell them, we make money off of them. So, profit and loss. And we were looking at the accounting methods for the profit and loss versus first in, first out versus last in, first out. Stacks and queues was the theme of this particular assignment. And I'm not going to go through the details of this. I'm just going to kind of modify it to make it work. And you can turn in whatever it is we do, the modifications that we do. You don't have to actually meet these unless you want to. Then you can meet these requirements. We built this stock last time, I believe. And it had the name, it had the number of shares, it had a purchase price. And I believe we also did... no, we didn't do the menu. I don't think we did the menu. We're going to put a menu together. So what I have left, and if you don't have it, again, go to, I should bookmark this. Go here and download this one. This is the one I'm starting with. It's called assignment number 3.zip. This is the one I'm starting with. In Eclipse. It's an Eclipse project, obviously. So let's see. We have a stock. Stock has a name, shares, and price. This is what we did last time. We have a default constructor. And what I'm also doing here is reviewing some concepts that you're going to see on the midterm, actually. Midterm is multiple choice, but you want to, multiple guess. But you want to, the more you know, the more you can guess, really. The more you can eliminate the bad answers, actually, is how that works. But anyway, this stock has a name. And then these are the access method, access modifiers, or access approach. Private means it's only visible inside of the class. Public here means it's visible outside of the class. All of our constructors are public. All of our data inside of the class object is private. And we use the public member functions to access the private data inside of the class. Just review that concept with you. These are the data types: string, integer, double. And we put in Java, in C++ you just put like public, colon, and then you list everything. In Java you put it on every single line. So in Java you don't really need to know C++ for this class, but in essence for Java the difference is if you know C++, you're putting it on every line, which I think is kind of stupid actually. I'd rather do it the C++ way, but anyway, I'm not working with C++, working with Java. So. Alright, so then we have the default constructor. That's this one here. The default constructor doesn't take on any parameters. That's what makes it the default constructor. And it doesn't have a return type. It just says public stock. Where down here, and this is a constructor as well, so none of the constructors have a return type because they don't return. They're just running. And then constructors, you always know it's a constructor because it has the same name as the class name. And it doesn't, the one that does not take on parameters is the default. Here's another constructor, same name as the class name, which is stock. And in our stock here, we have the name, the shares, and the double price that are being taken in. And we're setting this name, this shares, and this price, this meaning this object. And if you remember, super was the object above us. We can send super information if we want to run a constructor from the main parent class. We did that, or we may have done that with the dinosaurs. I'm not sure. We'll do it again later on when we do another inheritance example. But we have a method here called the get name or set name. Remember the setters and getters? That's what these are. Setting a name, getting a name. We have a set shares, get price, set price. And then I had this toString method that we did. And the toString method is one in which we were going to essentially return something when we try to print it out. So if we try to print out the object, we get something printed to the screen on a toString. If we take the object and convert it to a string. And so it automates it so we don't get a memory address, we actually get the name of the object or whatever it is that we have in here returning. So in this particular case, the toString method is returning the string name, this dot name. So that was the stock object that we created, and then we had the stock exchange, which was the main driver program that made an instance of the stock object. Actually, it looks like we made a couple of them here. We made Google, Yahoo, and Apple. If I remember, these are actually actual stock prices from what I remember, which is kind of ironic, given that Google is pretty expensive. Anyway, Yahoo's pretty low. Apple, I thought Apple would be a little higher than that, but anyway, we're not going to go through the stock prices right now. In essence, we created the 3 instances. We created a stack, and I told you about the Java util stack package. Now a stack, we're going to use the stack like a queue in this example. But know that there's other data structures that are available inside of java.util. So that's the time in which you would go to a nice little resource maybe for Java and look at the package contents of Java util. It's kind of like an encyclopedia. You've got about, I don't know, 50 objects in Java util maybe. Maybe more than 50, at least 50. I'm not going to go through each one of them, that would bore you to death. Instead, let's just work with a stack. A stack, you can actually use a stack like a queue, actually. The difference between a stack and a queue, and I think I was getting to that prior, maybe at the end of the last class meeting. A stack would go first in, first out, which mean, and I probably gave you an example of the dishwasher, unloading a dishwasher, and a stack of plates. If you remember stack of plates, the first one that goes in, excuse me, I said it wrong. The first one that goes in is the last one that goes out. So it's first in, last out. So we load stacked items, we put them on top of each other. So we have 1 on the bottom, and then number 2 goes on top of number 1, 3 goes on top of number 2. And then when we pull them off, when we remove them from the list, we're moving them from the top instead of the bottom. So the top would be the last place that we put in would be the first plate that we would take out. Versus the queue concept, the queue is the first one in is the first one out. So if we're at a bank and 5 people show up and they show up in the order of 1 through 5, the first person who came through the bank, number 1, would be the first person that would be served. Now a queue, in essence, as a data structure, is fair for order. A stack is efficient for processing. So most operating system functionality runs in the form of a stack, like the runtime environment stuff, because it's faster. There's no accounting. We don't have to keep track of who was first, second, third. We just load everybody up and then take everybody out, especially if you need to process the list. In fact, if we did a stack at the bank, it would probably run faster because you just load everybody in there, and then if you were working on the concept of just getting everybody served, and the average wait time for everybody is going to be, on average, a little bit better if you used a stack versus a queue, because in a queue you got to remember who was first, who was second, who was third, and there's more counting on the data structure. So it's not quite, like, on a stack you do a pop and a push. Push it on, pop it off, push it on, pop it off. On a queue you got an in queue, D queue. You got to find which end, you got to pick the right end of the structure, find the next item that was in the order, pull that item out, reorder the items. It's just a lot more accounting from a data structure perspective, but it still works at the same, very similar efficiency. Those are both containers. Stack and a queue is called a container, and a container is a part of a list data structure. So they're sort of like a list as well. A list versus a linked list. You can do a linked list as well. But this is not a data structures course, so we don't have to worry about that. I believe data structures might actually be taught next quarter. But if you're interested, I don't know. I'm pretty sure the class is going to be taught next quarter. All right, so here we created 3 stock, and then we created a stack, my stack, and then we put the stock in the stack. So we have my stack push Google, my stack push Yahoo, my stack push Apple. And then it looks like I wrote a little system out here. It says the first stock is Google dot, oh, I just printed out this one here. I didn't actually pull it from the stack. So if I run this, let's just make sure this thing runs actually. First stock is Google. Excellent. And I'm using the toString method that we did on Google, and that one prints out the toString method here. toString method prints out the name of the stock, this dot name. So that's where we left it off. Well, let's build the menu, and then we'll build some options, and we'll make some functions or some methods to do the things that we need to do for the options. So what we're going to do now then is, let's see, let's build a menu, because we can now review a little bit of basic programming skills. I'm going to take this as a, we have 3 stock, we put 3 stock into the stack, and we'll leave it at that. So one of the easiest ways to do a menu is to do like a do while and then put some options up there. And then, so we'll write the base menu, little text menu, and then we'll put some print system outs in the functions and we'll see how it works, kind of thing. So I'm going to start it out with a do, and then I'm going to put the opening and closing brackets, and then I'm going to put a while down here. And the while is going to be where x doesn't equal 5, and now I have to go back into the Java, or actually, while x is smaller than 5, and I'm going to use integer x as my kind of, let's see. There we go. We'll use x sort of like the control mechanism. So the menu is going to run in a kind of an endless, well, it's not an endless loop, it's going to be while x is, well, let's go smaller than 5. If x is larger than 5, so we'll make 6 the option to exit, then we'll have the ability to kind of control when the thing stops. So I probably could put x at the top, but I just put it right here. So then integer x is equal to 0. And then we're going to, let's see, let's do it this way. We need to get some input from the user. So we can use a system in, we can use a reader class. Let me find, hold on 1 second. Let me pause this for a second. I want to pull out an example. Okay, so what I just did, I put together what I call a cheat sheet. Actually, I'm not the only one that calls it that. A lot of people call it a cheat sheet. So I put it out here. It's called My Scanner, and it is out on the Sophia website. And so if I double click on it, you see what I'm talking about here. This is a Java program that demonstrates console-based input and output. So we've looked at system out so far, but we haven't looked at system in. System in is kind of a crude way of doing it. We could do it with system.in, or we could put together what's called a scanner. So here we're going to create a single shared scanner for keyboard input, as my cheat sheet says. It's actually taking system in and it's wrapping it so that the input is actually formatted for us. Otherwise, we would have to take it like word by word. Now we can take it like line by line, and we can do a lot more with it if we use an instance of the scanner class. So here I have a private static scanner. So it's a scanner, new instance of scanner, which is equal to new scanner, system input. And I put this out here so that I can use it everywhere I want inside of the particular class implementation. So in here, there's a little prompt. If I actually, and I'm gonna, in a few minutes now, I'm gonna cut and paste this code and stick it into our stock exchange main driver program. And I'm doing this so I can avoid typos. And you can do the same thing yourself if you can get to this website. So I'm gonna put this, it's called scanner. I'm going to copy it and stick it inside of my Eclipse. And so I'm going to stick it right here up on the top. So I want to demonstrate another point too, actually. Edit, paste. If I stick it out here, I've got a global, if I want to call it a global, I have a variable that I've created called scanner, an instance of an object actually. Hold on 1 second. Okay, so now that we have a few things taken care of here, so I'm making an instance of an object called scanner, and I've done it out here in the main stock exchange class. which means inside of this method and inside of all of the other methods that I have, I'll be able to use this. It becomes global, it becomes something I can see everywhere. Now, it's static because it's at the class level. So static is a keyword that we use to make something a class versus an instance, or an instance. So normally we haven't been using the keyword static. Instead, on main we use static. So static as a keyword, this is review as well for the midterm, because the keyword static is on the midterm. This makes it a class level, which means we can use it anywhere we want. We don't have to make an instance of an object and run it, because there's no instance of this main driver program that we're running. We're just running the driver program. So I'm going to show you something here that's actually kind of cool with Eclipse. See how it's red and it's underlined, and it basically thinks that we have an error message. So I'm not sure if I showed you this, but I want to show it to you with this one. If I hover my mouse over and I look at that, I can see the first item is going to be, and what we have are 6 quick fixes. A little cheat sheet, actually, again, in Eclipse that helps us trying to figure out how to fix something. If I hover my mouse over input, which is the one I want, generally the first one is the one that's going to be the best option. So I need to import the scanner from java.util. So if I click on that, you see at the top, my import now says java.util.scanner. So now I've imported scanner. And so now my little error message goes away. Now instead I have a yellow curly underscore thing that says, well, we're not being used. So if I hover my mouse over, it's going to tell me that the value is not being used. Yeah, I know, I just created it. It's not going to be used yet. So I'm going to use scanner, and we're going to see scanner in a few minutes to get input. And we're getting it from system input. So I know there's some interesting spaces here. We don't really need those spaces, but we're using the constructor from scanner, new scanner, with system in, just like we're doing system out. So we have system out down here. So the first thing we want to do is print the menu to the screen. So now I'm back down here. I put this up here because eventually I'm going to use scanner, and we'll see scanner used in a few minutes on how to actually get the input from the user. So in the do while loop down here, I'm actually going to create the menu. So I'm going to go system.out.println, and I realize that system needs to be capitalized. And I'm going to put a title out here. This one's going to be Welcome to the Stock Program. And then, let's see, I'm going to go at system.out.println. I'm just going to put a blank print line in here. Remember, if we don't put any arguments in here, it just prints out a blank line for us. And then I'm going to put my press 1 for this, press 2 for that kind of thing. So this is a low-tech menu. This is a low-tech kind of, we'll see the menu run in a few minutes, but it's definitely not what I'd call sophisticated. So select one of the following options. You can make your menu look any way you want. 1, so you press, I'm just going to go 1, 4, and what are our menu options? Let's take a look here. 1 to enter a new stock, 2 to find a last in, first out, and first in, I'm going to separate that into 3, because I think it's easier to do 3. So 1 to enter a new stock, 2 to do last in, first out, 3 to do first in, first out, 4 to exit. That sounds better to me. So let's go ahead and do that. So 1 to enter a new stock. Actually, I'm going to put input. Create a new stock. I guess I could cut and paste here, but I'm just going to type it. To first in, first out. Oh, you know what? I'm going to do a stack. Return stack. Return like a stack. I'm changing my menu options. You can do anything you want with yours. return like a queue. Because really that's what we're doing. And then when to exit. Say 4 would be to exit. Exit. Exit the program. So now, while x is smaller than 5, well, let's go here. While x doesn't equal 4. That sounds pretty good. So right now, the menu is just going to print out on the screen, and if we want to see it, because nothing's going to happen yet, but if we want to see the menu printed out on the screen, I've got an endless loop going on here. So because nothing's happening here, I'm not stopping it at all. And hopefully I've saved it because now I have to, now I have to figure out, what is it again? Control something? Oh, yeah. There we go. Thank you. Thank you. There we go. Not the best design, because ideally we need to stop and ask for some input so we can change the value of it, which is what we're doing next. So the menu actually looked pretty good. So now what I'm going to do is come down here and where it says select an option, at the end I'm actually going to have it select an option. So I'm going to go back to my little cheat sheet that I pulled up before. And so now inside of main here where it says prompt the user, it says type some data for the program, right? And then we have this line underneath it down here where it says string input. So we're going to create a string called input. It's going to be equal to the scanner.next line. So we're going to basically get a string from scanner. Scanner is this object that we created up here using system input as the source. So we created a new object, ran a constructor to do the system on the system input. It's going to create a string for us automatically. In this example, it just prints the string out. So I'm going to actually just copy this. So you just need the line, you don't need the comment. But I'm going to copy it, stick it in here. Where it's going to read the line in from input. And then instead of input, I'm going to make it X. Actually, let's make it input. Input. And then we can take X and have it equal to parse int of inputs. And now I have to remember, nope, input.parseInt. I'm doing JavaScript right now. Inputs. Ooh, you know what? I can just do this actually. Integer from input. Nope. Nope. String is input's an object. Compare to. No. Let's do it differently. Let me think how I want to do this. Inputs. I could do this. Okay, so I can parse the input from a string, or I can use the string as a value. Do I want to use the string as a value? Oh, I don't know. I could test the value of input and not use X. Then I have to do a contains, because the input's going to have like a line return on the end of it. Well, let's proceed this way. Let's see. I can't do a string to, I can't take an object. Okay, so input's an object. It's an object of type string. The string is an object. Integer is not an object. Integer is a built-in variable. So we could parse, We can't parse an object to a primitive. That doesn't work that way. Instead, let's see. No. It's not going to be compatible. It's going to tell me that it can't cast a string to an input. Let's leave it. Let's leave it as a string. String input. Let's see. Hold on one second. Pause this for a second. All right. I guess if I had decided ahead of time what I wanted to do, it would have worked a little bit better. But let's just do it this way. I didn't want to use integer because integer is like, this is a class we're running. Okay, I guess this is a good learning opportunity then. String is an object, and the object is actually not convertible to a primitive. Integer is a primitive. We've created, what I mean by primitive is a built-in data type. It's not an object data type. So integer, float, double, those are all built-in primitives. You can't go object to primitive in a conversion. I could typecast it if it were integer to integer. For example, if I did this, I could say double D is equal to, if I wanted to do it this way, I could say double to cast it from X. And that would do a typecast to a double type from X to make it a double, which is what I originally wanted to do with the integer X. However, in this particular case, maybe this does tie in with static. This is a parseInt is a static method that we're running on the object class integer, which happens to be the integer equivalent object. So it's actually an equivalent object that casts to an integer object, which is not what I would call a safe cast, but it works just fine, and it's the only way you can do it, really, from a string to an integer value to do a parseInt. Because integer is actually an object as well, but it is a more compatible object with int. So if we system out here, system.out.println, I want to just check the value of x first. System.out.println, and make sure that x is something that we want. So x is x. So we know that that's what we want. So if I put in 4, I should get 4 printed to the screen. And then I should get, if x doesn't equal 4, it should exit out. So let's see real quick here. So now my program stops because my system input is waiting for the console input to come in. So it says, welcome to my stock program. I'm going to actually put in the number 4. Oops, except for I'm doing it up here. Let me do it down here. Looks like I need to put a line return at the end as well. But when I put the 4 in, you can sort of see it green on the bottom here. And it should say X is 4. First stock is Google. Well, that's because down here I have this printout. I have this system out down here. So now I know I'm going to put another print line at the end here. System out.println. Clean up my menu a little bit. So my menu is now working properly, and here I can put a little space in here. I don't necessarily need to leave this in here. I'm going to leave this in here for troubleshooting so I know which menu option is being selected. But now what I want to do is create some menus or some activities that are going to occur when the menu items are selected. And I'm going to put that down beneath here. So I have my input. I know what I'm going to do now. So now I'm going to put in a case switch, I think, and then put some menu calls, or some function calls, I should say. So I'm inside of main, so I'm going to run outside of main. I'm going to create my menus. So out here, I'm going to put my methods in. So these are going to be methods to run functionality. I'm going to stick it outside of main. My main method is the one that's going to be running my driver program here. So let's see. I'm just going to put some generic stuff in here where it's going to go 1 through 3, because 4 is already going to exit me out, because I already have that where x doesn't equal 4. If X does equal 4 at the end. Actually, here I can change this one and say, bye-bye, system.out.println. Thank you for using my program. Thank you for using the program. There we go. Okay, so let's see. So I'm going to put in a switch, and I'm going to put the switch on X, and I'm going to have a case where it is equal to 1, a case where it's equal to 2, and a case where it's equal to 3. Remember the switch case from last time. This is also a little bit more review. So I kind of like wanted to do this in the morning before the midterm because now hopefully you'll be thinking in Java, hopefully. So case 1, I'm going to run the method now. What method am I going to run? I'm going to run one that's going to be called create a new stock. So this one's going to be called new stock. It doesn't exist yet. And then I'm going to put a break in here. So down here I'm going to create new stock. And this one's going to be void new stock. So I put this method down here. I can put public next to it. So I can make it like, public void. Let's do that. It is a public method. And void means it doesn't return anything. It's just going to do something for me. The other ones are going to return something for me. Or maybe they don't really have to. None of them really have to return anything. So let's see. It's a static method. I need to put static in there. So change new stock to static, which I just did a few minutes ago. So again, static, we're really looking at a lot of static stuff here today. Static is basically meaning it's run from the class level, just like main is run from the class level. And just like up here, scanners run at the class level. So we're not working, static is like the opposite of object orientation. We're not really working with instances of objects or methods from objects. We're working at the level itself, just like integer here. This is a static method, parse int. And we ran it from the integer class, so which is why we put the name of the class in there. Anyway, so now I have a public static void new stock. We haven't seen static very much right now because in the past, like the last couple weekends, because we've been making instances of objects and we've been making methods inside of them, and we've been running them a little bit differently. So let's see. But in a driver program, it's not unusual to see a lot of static methods. So I'm going to make another one, and I put a break on here because I want one to end. So if I really wanted to test it inside of new stock, I could put a system out, system.out.println, and say inside new stock. Because now I can do this. I can go. I'm going to copy it, actually, this time. I'm going to make 2 more static methods for my option 2 and option 3. So, let's see. And I'm going to get some errors because I know it's called the same thing. I have to change the names. So this one's going to be stack functionality. I think I put stack first. So I'll put in here new stack. Probably not such a good idea to use the word new in from here, but anyway, new stack, new queue, or use stack, use queue. I'll do that. New stock, use stack, use queue. Use stack, use queue, and then I'll change it in here so it says inside of stack, inside of queue. That looks pretty good. And, okay, inside of new stock. Good, 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 good. Inside of create a stock. So then up here I'm going to write the same 2 lines of code I did. I'm going to write 2 more lines of code that are exactly like the first one, but this one's going to be use stock. stack. And then use Q. Okie dokie. So now I should have the functionality working for my menu. Let's just take a look here. I'm going to run it through. Let me comment out this line of code here. That gives me my stack. So I'm going to test out my menu. Make sure at least my menu is working correctly. So I'm going to press 4, and 4 is going to exit. It says, thank you for using the program. And now we're done. So now I have to run it again. Oops. It's on the screen here. It says inside, it scrolled back up. So I moved my pointer up so I could scroll up the screen a little bit. It says inside of stock, create a stock. I pressed 1. So if I press 2, it says inside of stack. And if I press 3, it says inside of queue. And I press 4. So I know my menu is working right now, which is good. So now that the menu is working, we can build the functionality inside of the different methods to make the menu work, have it do something. And we could prompt it, for example. So let's see. We have 3 stock that are in here. So this one here says create a new stock. So we'll work with number 1 to create a new stock. So we should probably prompt the user to enter in the name of the stock that they want to create, maybe, and give it, so we probably want to enter in the stock name, and then we'll just, we can enter in the number of shares and enter in the price if we want to as well. Then we got to parse int, parse float, parse double, or we can just set it automatically with the name. So I'm going to shortchange this a little bit because it's kind of tedious. So in here, I'm going to say insert inside of create stock. So I'm going to change this because I don't need this anymore. This was for testing. I'm going to say enter the name of the new stock. And if I take out the print ln and I just put in print, and I put a little space here next to the colon, it'll show up on the same line. And then I'm going to go back up to this line of code up here I used for the scanner, and I'm going to reuse the same scanner. So I'm going to create, we already got the string actually. In fact, if I wanted to, I can come up here and put private static string input. Now I'm going to create the same thing I did before, so I don't have to keep going string input, string input. I just go input, input. So down here, I could just say input. Now I could just use input anywhere I want, because I made this into it's visible everywhere because it's inside of the stock exchange main class. So inside of this method, it's visible. Outside of this method, it's also visible inside of this method. So if I did that, I could go like this and say paste input equals scanner next line. And so then I have the name of the stock. Well, ironically, I want it to keep it as a string because I believe I have a method in here. It creates a stock with a name. Or does it? Yes, it does. No, it sets name. Do I have well, I just use it. We can do it. We can just set the shares to 0, the double the price. Or we could ask the user for all that stuff too. No, let's just do it once. We'll ask the user. So if I want to, and then I can make some temporary variables if I want. I can say, like, for example, string name is going to be equal to input. And then I can say, I'm going to copy this here. I'll just do it. We'll just do it. Edit copy. I'll have it edit we'll just do the number of shares. So enter number of shares. And I'll put put a line in between here. And then input's going to be, so let's go here. This is enter shares, so I'm going to go at integer shares. It's going to be equal to integer parse int with the input. Same thing we did up above. So integer shares, yes, I know it's not used, and name. And so then I can go ahead and create the instance of the object. And remember up here when we created the instance of the object, we just created a stock, and then we took the stock and we put it inside of the stack. But remember, we did this actually out here. I could make a static stack. I could make well, if I do that, I could make the stock here, no problem. Watch this. I'm going to do this, actually. Paste. So new stock, I'll just call this new one. And this one's going to be share, oh, this is going to be name. No, this one's going to be called name. And this one's going to be shares. And then, I don't know, I'm just going to put it in as a price 100. We could ask the user to enter in the price. We could parse it into another integer, another double or something. Or float. We could actually do a float if we wanted to. Or I'm just going to put it in here. And then I'm going to see that this particular stock object that's created is inside of the scope of the new stock static void method. And then the other protocol here that we were doing is we were adding it. So we were going my stack dot push, and then we're pushing in the new stock. So watch what happens down here though if I go my stack dot push. And then what am I going to push in? New one. I get this little thing up here that says that it can't create local variable my stack. There's no local variable. So I can do the same thing as I did before. I can actually create the stack outside of main and make it static, which is what I'm going to need to do to fix this. So if I take this and do the same thing I did with the input, stick it out here. Let's see. I'm going to say generic type, suppress raw type stack. Doesn't matter. We'll just leave it alone. Yeah, I don't want to go into types right now. I need to make it static. So let's see. There we go. Static stack. My stack is equal to new stack. I didn't type the stack with a stock. It's really a stock stack. I want to get into that later though, because this is way above and beyond what I want to do for this example. When we use a generic, what we've done here is we've created a stack, and the stack is from Java utils, and I didn't type the stack. Oh, I said that correctly. Good. It says stock and stack, and she sells the seashells on the seashore. This is really difficult for me. Anyway, bottom line, I didn't type it. I could type it so that the stack holds integers, stock, floats, but I didn't do it. If I did it, I could suppress the warning with raw types, which is what I'm using, but I don't want to do that. I'm going to leave that alone right now. So instead, it's going to tell me down here that it is of raw type. Yes, I know. We're going to leave it alone. But instead we're going to notice down here that the air went away. So now I've made it static. It is of class level, and I can use it anywhere I want. So if you want to think of it like old C programmers that thought of this like global scope, it's kind of like global scope, but it's not really a scope thing. It's more of a visibility thing. So anyway, static. In fact, if I wanted to, I could actually put the word private here as well. That would make it so it's only visible inside of this particular object. This driver program. To be consistent, I'm going to make it consistent that way, actually. So now we should be able to run this function, and it's going to put a new item in there. And if that's the case, then the same thing what we did. In fact, let's just run it, make sure we get a new one. So I'm going to have to select item number 1. It says create a new stock, and it's going to say enter the name of the new stock. I'm going to say, I don't know, pizza stock. Enter the number of shares, 12 shares. And then, well, that's it. I didn't do anything with it. I just put the pizza stock in there. Let me do 4 to exit then. Okay. So now here, I have to use it like a stack or use it like a queue. So it is a stack data structure by default because we created it using util stack. So we have a pop and a push. The push pushed it on, and hopefully I did push it on. What did I do here? Yes, I used a push here to push it on. So the no-brainer is to use it like a stack, and then when we used it like a stack before, I left this line in here where we, oh, actually this just printed out the Google stock. It didn't actually didn't actually pop it off. If I wanted to pop it off, I could peek at the next one or pop it off. So in this particular case, use it as a stack. I'm going to take one off the top, take off top. And if I take it off the top, I want to show what it is. So I'm going to go system.out.println, if I could spell system. I'm going to leave this empty for a second because I've got to run a stack operation. So I'm going to say it's my stack dot pop. If I pop it off, it takes it off. If I peek, it'll tell me what object is there. So if I peek it, it's going to tell me, it's going to return the object that's on there. If I peek it, for example, here, it's not going to do anything unless I system out it. If I system out it, I'm going to have to go copy the peek stock to a stock. So I could go, this is a stock. So let's see. We'll just create a new stock from it. Stock, peek stock. Equals my stack. I have to add a cast to a stock to peek it to a stock. The item in the stack is going to be the one we're looking at. It's casted as a stack item. It's a stock inside of the stack. If I peek it out, I'd have to, in fact, in this particular case, I'd have to go peek stock dot to string to actually get the name of it. So in here, I'm going to go, let's just see if this works first. Peek stock dot to string. It'll be incredible if this actually does work. Let's see. Let's see. I'm going to put something in here. Item on top is peek stock, which is a stock casted from the stack, my stack peek. Let's see if this actually works. So this is item number 2. Yep, the item on the top is apple. Well, I didn't put pizza in there. I have to put pizza in there, and then because apple, the item on the top is apple. Oops, let me exit out of here. We put Google, Yahoo, and Apple in that order because Apple got put in last, or Apple got put in first. Apple got put in last. First, second, third. This is the first one. Oh my god. Second one. This is really taxing today. First one, second one, third one. If we pop it off, which we did, Apple comes off. So we could play around with this for a second. Let's put the pizza stock in, and then we'll pop one off, and we'll see what happens with this. So let me run this again. I'm going to create a new stock. So I'm going to run number 1. Oops. Hold on 1 second. Let me stop this for a second. It's because I'm typing into the code, which is not good. Okay, run. Okay, number 1. Enter the name of the new stock. Pizza. Pizza is the one I'm putting in right now. Enter the number of shares. I don't know, 1. Oh, it's not going to, it doesn't give me any self-satisfaction. It won't even tell me anything. I should probably put a message on that says, thank you. Anyway, so now I'm going to pop one off. So I'm going to return like a stack, number 2. So I'm going to run number 2 option. And then it's going to say topped off the top. Item on the top is pizza. That's the one I just put in. So I populated it with those Apple, Google, whatever that was, Yahoo. Initially, so I would have some stuff on there. So I don't necessarily need to run option number 1 anymore. I know option number 1 works. Number 2 is usually like a queue. So if it's like a queue, then on the bottom here, so let's say, I'm just going to copy this here, because we're going to do a very similar operation. Down here where it says use like a queue, get rid of this line, edit, paste. So this is Q. Q is like the worst thing to try to spell. Q output is, and then my user input, my user, we're not going to use a peak this time. Instead, I'm going to go my stack dot DQ or first element. First element in the queue instead of the last element in the queue. Is that actually going to return the first element? Let's see. I don't want to call it peak. I'm going to call it first stock. Let's see. I'm actually kind of curious, actually. I don't know. This is really an experiment. I think first. Hello. Plus first. I think first stock is going to return the first element. Would it return it and put it into first stock? Let's see what's going to go on here. Does it work? Okay, good. So number, the first element is number 3. And it says it's Google. Item, well, item on the top is Google. Did I put item on the top? Yeah, take off the top. What did I do here? Q output. Oh, number 4. Hold on 1 second. I ran the wrong. I ran 2 instead of 3, I think. 3. 3 says Q output is, oh, I didn't change the other. It's actually item on the bottom. You're right. It's working. Okay, so it's Google. So this one here is item on the bottom. Item on bottom is the first stock. So you can see what this is really doing is demonstrating if I were to pop it off, to NQ it, to get the first element, to peek at the top element, to peek at the first element, what I would do in my program is if I was keeping a bunch of data components, I could stick them into a stack. I could use the stack data structure as a queue by going onto the other end. You don't need a different data structure for this. You can actually just use a list for this as well. We used a queue so we would see the pop and the push functionality. On the queue, we get the NQ and the DQ functionality. It's really kind of similar. It's very same. Pretty much the same. If you go and you look at the stock, for example, let me have some space here in the code. So I'm going to go my stack, and I'm going to go dot, and I'm going to take a look here. You see where it says like push, empty, pop, size. I can see I have a bunch. I can clear the entire stock element. I can add an item to add all. I can check the capacity. I can clone one to another. I can see if it contains an item. I can find a stock. Does it contain, and then use the toString to have it equal to a string on a stock item. First element for each, I can have it do something, get the class, see what it is, see if it is a stock. Anyway, so you can possibly say remove all, remove item at element number. I can see what element numbers. I can use it like a list. So the data structure itself is a built-in as a built-in object. The data structure itself is really quite quite useful as a generic data structure. So I believe we did this. Let me pull this guy out here. Clean this up a little bit. These are methods to run the functionality for the menu. Okay. See if there was anything else I missed. I think we got it. Let's see. Well, we didn't do the accounting. If we did the accounting, we'd have to pull the price out. If you wanted to sell a stock, as an example, okay, let's add another menu item to sell a stock, and then we could do some math on the price of the stock. So let's see. I'm gonna make now item number 5 is to exit. So I'm gonna change my loop here to say it doesn't equal 5, and I'm now gonna add item number 4. Sell a stock. Calculate profit. Calculate sale. That's pretty generic. Calculate the sale. And then I'm going to write another method down here. It's going to say, let's see, calculate sale. Run sale. Do sale. Do sale. There we go. And then up here, I'm going to change the logic here to add another one, case 4, to do sale. So I've just added another menu item to do a sale. What we're going to do is do another method inside of stock to calculate profit or loss. And we'll have the stock do it ourselves, actually. So let's see. This one is going to say sell a stock. So let's just sell the last stock. Last stock we put in there. And then, so we're going to use the peak here. I'm just going to do it this way. And you could possibly see that the scope of this particular is not static. So I keep having to do a stock, peak stock. So I'm creating the peak stock over and over again inside of each one of these methods because I'm not using a static object. I'm using a local object inside a method object. So it's not a bad practice. It's just when you want something to be visible global, like the stock itself, like the stack itself, it's better to make the stack a static variable. That way you can add to it from other different methods and use it kind of in a global context. So let's see, we're going to peek off the top one. We're going to sell the we're going to sell the stock. And so we're just going to, we could probably build some better functionality in here, but I'm going to actually add a line in here to do some more input. I'm going to say, in fact, I'm going to do this here just because it's easier. I'm going to cut and paste down here so I don't have to worry about typing again. And so this is going to be functionality to calculate profit. So enter sale price. Enter sale price. So then we're going to read it in, and then we're going to parse it into price. So we're going to take the input. We'll just use an integer. It's okay. And then we're going to get the stock, which we've already done. We've peeked out. So we have peeked the stock. We have a peak. We have a stock now. So now we can run a method on the stock to get the price. So for example, we can say that integer s price, stock price, is equal to peak stock dot get did we get a price? Here we go. Get price. That's a double. So we can go double. And then we can take, we'll just play around here. Could parse double. Nah, we'll just leave it as an integer. We'll just take the double and do it. We'll just subtract it out. It'll work just fine. So then I can say, let's say double profit. It's going to be equal to cast the price. Price minus S price. And let's see what I've got going on here. S price, extra, I have extra something in here. X price, double. Let's just do this one here. Double price minus S price. Error token. Oh, yes. Okay. So the profit's going to be the double value of price minus the S price. Considering that S price has to be higher, so we have to put a big number in for the profit price. And then I'm going to system out profit is. Assuming that we have a profit, that is. And then I put profit. Okay, so what I've done is I've tried to demonstrate running a different method. Instead of the toString to print it out to the screen, instead we took the price, we took and we popped out, we peeked the top item off the stack, turned it into a stock. We took the stock and we ran a get price method that returned the price of that particular stock item. And we're going to take the stock price, S price, and calculate a double profit from that. By taking the double price, we took price in as an integer, we could have taken it as a double. I just wanted to show you, you can cast an integer to a double, a double to an integer. We don't have to do it this way. We probably should have just taken it and parsed a double out of that. But anyway, bottom line, double price minus S price to equal to profit. So let's see, how much was our, one on the top is Apple. Apple is $123. So we have to put in something higher than 123 if we run it. so let's go ahead and run it. This is going to be 4. Enter the sale price, 200. So it says that the profit is $77. 123. Yep, that's right. Okay, good. So we did our math correctly. So we have now a new item. This is calculate a scale. No, it says sale. Calculate a sale. So I don't think I can do anything more with this program. I think this program is pretty complete. Unless somebody wants me to do anything more with it. I think it's done, actually. Yeah, I think we're done with this one. All right, so I'll upload this, but, and I'll put this as finished. I'll call it finished 1, finished number 3, because there's already a number 3. Huh? For the switch, I'm so sorry. Let me put this back here. Switch code is right here. This is what the switch code looks like. I changed, I didn't test number 5, but I want to say that number 5 probably does work. I changed, because I added number 4 to the menu to run this one. I will upload this, though, to the bhacker.com/Sophia website. I'll leave the original number, assignment 3, and I'll put this as the finished assignment number 3.